In this video, I'm going to show you how to use a standard normal table to find the area under different normal curves. And so we're going to start out, notice up here at the top, we've got how to solve problems involving normal distributions with the standard normal table. So the first thing we have to do is write out the problem in terms of the original variable. And so notice our example says IQ tests are designed so that the IQ scores are distributed normal with mean of 100 and standard deviation of 10. What is the probability that a person has an IQ larger than 113? So that is the statement in terms of the original variable. So next we're going to draw a picture of the distribution and shade the area of interest under the curve. So we're going to start out by drawing a normal distribution. And notice that we have a mean of 100. So for the IQ scores, we have mean 100. And the variable we're interested in is the 113. So notice 113 occurs to the right of 100, so I'm going to draw it there. And then next what I'm going to do is, since we want the probability that a person has an IQ larger than 113, is I'm going to shade all of the area to the right. So I'm going to shade that in, and that's my goal. If I can find what this area is equal to, then I'll know what that probability is. But unfortunately, we don't have a table that tells us about normals that are centered at 100. Instead, we have what's called a standard normal table. So in order to use the standard normal table, I have to standardize this value. And so standardizing the value, we have z is equal to the value I'm interested, 113, minus the mean divided by the standard deviation. And if you put that in your calculator, you should find that that is 1.3. And so this normal right here, this is our original normal. And what we're doing is we're converting this over to a standard normal. So in terms of the standard normal, if we draw a picture, the standard normal is going to be centered at 0, and notice that 1.3 is to the right of 0. And if I shade in this area here, what we have done is this area and this area are equal to one another, and we can use the table to find this area. So how do we do that? Well, how you want to think of your z as being written is you're going to have a number out front and then 2 decimal points that trail. So I'm going to go ahead and add 1.30. Now let's go look at our normal table. So our normal table is going to give us the area to the left of any value. So the z values are going to be listed along the left-hand side. And remember, we're interested in 1.30. So notice these are all negative, so we're going to keep on going. And if you scroll down to the next page, we start to see some positive values. And notice right here we see 1.3. But remember, we had that second decimal place that we were interested in. Well, that second decimal place we're going to find here along the top. So 1.3, and then we go to the 0 column, gives me an area of 0.9032. So if we go back to our picture that we had, what this says is this area right here is equal to 0.9032. But remember that the total area under the curve is 1, so this area right here is equal to 1 minus 0.9032, which is equal to, we're going to put that in our calculator, and we find that that's equal to 0.0968. So therefore, the probability that a person has an IQ larger than 113 equals 0.0968. Now take a moment and go back and look at this same example when we use the online applet. When we used the online applet, we found that this probability was equal to 0.097, which if we round this, that's the exact same value. So we could use the table, or we could use the applet and find the exact same value. So let's do another example. This one says IQ tests are designed so that the IQ scores are distributed normal with a mean of 100 and a standard deviation of 10. What is the probability that a person has an IQ smaller than 96? So the first thing we're going to do is draw our normal curve in terms of our original variable. So again, IQ scores are centered at 100, and we're interested in an IQ score of 96. But this time, we want to know the probability a person has an IQ smaller than 96. So we're going to shade in the area to the left. And then my next step is I have to standardize this value. So to standardize the value, I'm going to take z equals 96 minus 100 divided by 10. So take just a moment and put that in your calculator. You should find that you get negative 0.4. And to be more specific, let's put the 0 out in front of it, so this is really negative 0.40. Because remember, when we have these z-scores, we really want to take this to 2 decimal places out here. All right, so if I think of my standard normal curve, what I'm looking at, it's centered at 0. So negative 0.4 would be down here. And this time I want the probability a person has smaller. So drawing my line, I'm going to shade this in. So this area and this area are exactly the same. So let's go and look at our normal table. So looking at our normal table, our z was equal to negative 0.40. Well, looking along the left-hand side, you should see all the positive values. So if we scroll up to the first page, we see some negative values. And remember, we were interested in negative 0.4, and then we wanted a 0. So if we scroll back up to the top, we see that this first column is our zeros. So the probability that we want, or that area, is 0.3446. So going back, we know that this area right here is 0.3446. And notice this time we don't have to take the 1 minus because the table gives us the area to the left. So we know that the probability, and let's for shorthand use our probability notation now, that the probability that IQ is less than 96 is equal to 0.3446. Now take a moment and go back and look at the previous page where we worked this problem using the applet, and you'll see that we got the exact same answer. All right, let's look at the next one. So the next one says, we're interested in the probability that a person has an IQ between 2 numbers. So how could we do this one? So we'll start out by drawing our picture. Again, IQs are centered at 100, but we're interested in the area between 112 and 125. So now we've got 2 variables that we're going to have to standardize. So let's do them separately. So now I'm going to write z, and I'm going to put just the subscript 112 here. That's just to remind me that this is going to be the z-score for 112. So I'm going to take 112 minus 100, divide it by 10. If you put that in your calculator, you should find that's 1.2. Then we also need to find the z-score for 125. So again, that subscript is just to remind me which z-score is which. So I'm going to take 125 minus 100, that is 100 up there, divided by 10, and you should find that that is 2.5. So in terms of our standard normal curve, which is centered at 0, we want the area between 1.2 and 2.5. And remember that these areas are exactly the same. So again, what we're going to do is we're going to go to our standard normal table. The first one we're going to look up is the left one. So we get 1.2. So again, we're going to start here on the left. These are all negative values. So we've got 1.2 and then 0. So 0.8849. So going back to our picture, that tells us that this area here is 0.8849. Now notice when we look up 2.5 on the table, it's going to give me all of the area to the left of 2.5. So we go back to the table. Scrolling down to 2.5, we've got 0.9938. So let's kind of change the color here to help us see this. So what this is saying is all of the area in red, going back and double checking our table, 0.9938 is 0.9938. Well, if we take the red area and we subtract off the 0.8849, we'll be left with the piece that we want. So what that tells us is the probability that IQ is between 112 and 125 is equal to the red piece, 0.9938, minus 0.8849. And so again, take a moment, put that in your calculator. And you should find that that is equal to 0.1089. And if you go back and look at the example from where we used the applet, that's the exact same answer that we got when you round up.